So what are you guys?
We're part of the Smartwood family.
Hey guys, so today we're going to do a quick problem. We're going to look at the numbers from 1 to, let's say, 10. Okay? And we're going to pick 3 of them. Okay. But the trick here is going to be this. We're going to make it so that none of the numbers can be consecutive. So for example, 1, 2, 10 would not work because 1 and 2 are next to each other. Okay? The question is, how can we do this? And it's nice because, it shows the creativity involved because you can do it so many different ways. As long as your thinking is sound, you'll get the right answer. So let's do one way. The first approach is going to be like this. Let's say, well, first a quick review. If you did 10 choose 3, right? Remember that's equivalent to 10 factorial, 3 factorial, 7 factorial, like this. Okay? But the point is, this is where you have all 10 numbers, you pick any 3 of them, and the order in which you pick them doesn't matter. So for example, if you pick 1, 3, 5, or 1, 5, 3, these answers are considered the same. Okay? So, all right, so this is just going to be 1, 3, and 5. Okay. So now, that's obviously not the answer we want, because if you're just picking any 3 numbers, you can obviously pick numbers like 1, 2, 10, and we know we don't want that, right? Okay. So what's the adjustment? How are we going to fix this? Well, first, I kind of want to observe this. If you take any of these numbers, obviously whether they come in as 1, 3, 5 or 1, 5, 3, you can always put them in order, right? And since we're picking out numbers, we're not replacing them. In other words, you're not allowed to pick, say, 1, 1, 2, right? All the numbers have to be different. You can think of it as counting guys like this, right? In fact, if the question were something like this, how many ways can you get 3 guys that are set up like this where A1 is less than A2 is less than A3, and you're picking these numbers from 1 to 10, that's literally the same, right? The number of ways to do this is 10 choose 3. Okay. So now the problem is if you want to impose this condition that it can't be back-to-back, none of the numbers can back-to-back, you kind of have to ensure there's a gap between them, right? So maybe if we did something like this, that ensures there's a gap. Because what it's saying is it's not enough for A2 to beat A1. A2 has to beat A1 by at least so much that even when you take 1 away, he's still bigger. So for example, if we said A1 is 1 and A2 is 2, that's not going to work because 1, the gap here is not big enough because when you subtract 1 from 2, you get 1 is less than 1, and that clearly doesn't work. Okay, but if we said A1 is 1 and A2 is, say, 3, right? Then clearly A2 is bigger than A1, but we're saying the gap is big enough because when you subtract, A1 is 1, right? But A2 minus 1 is going to be 2, and we're good. Okay? So what we're actually doing, if you think about it, is we're looking at the actual guys, A1 and A2 that we're picking out, but we're translating them by doing this minus 1 in such a way that guys that work up top correspond to statements that are true here, and guys that don't work up top, like 1 and 2, correspond to statements that are not true down here. Okay? And you're like, well, why the hell are we doing this? Because up top, right, it's complicated. It's complicated to think of guys where you're picking out 3 and they're not back-to-back, etc., etc. But down below, if it's really simple, once we translate, if it's equivalent to just picking out 3 numbers, well, we know how to do that, right? If it was 10 guys, you pick out 3, it's just 10 choose 3. So the goal is, by doing this modification, we'll translate something kind of stressful into something that's smooth, right, or easy. So let's try this again. Well, the problem is we're not picking 2 numbers, we're picking 3. So we may think we can do this. And that would definitely ensure that A3 is bigger than A2 is bigger than A1. But the problem here is this. Again, if you think of this guy as a quantity and this guy as a quantity, the guy on the right is bigger than the guy on the left. But there's no gap between them because you're subtracting 1 from both guys. So A3 and A2, there's no gap between them. Well, let me rephrase that. There is a gap between them, but it might not be big enough. So for example, if I pick the numbers 1, 3, and 4, these don't work in our setup, right? So let me be clear on this. If A1 is 1, A2 is 3, and A3 is 4, right? Okay, these numbers don't work because 3 and 4 are back to back. But when you do this test, A1 would go to 1, A2 would go to 3 minus 1, which is 2, and A3 would go to 4 minus 1, which is 3. So the problem here is this is a setup that we don't want. But when we translate it, the statement you get down here is true. And that's not going to work for us because we want to have a setup where only the numbers that are legit up top give us true statements and numbers that don't work out give us false statements. So then if in our translated version, if we count the number of correct statements, right, we'll get what we want. Okay, so how do we fix that? Just like before, if you think of this as a quantity and this is a quantity, to ensure there's a gap between the two, maybe one adjustment should be this. We'll take A2 minus 1. We'll have it be less than A3 minus 1. You can kind of think of it this way. It's just this guy is bigger than that guy, but I want there to be a gap. So I'm going to put another minus 1. Okay, so let's try that. So then we'll have A1 is less than A2 minus 1, and that's going to be less than A3 minus 2. Okay, so pick numbers that don't work, like 1, 3, and 4. Will that translate to a true statement once we do this work? Well, A1 is going to be 1. A2 is 3, but when you subtract 1, you're going to have 2. That part's true. But then over here, A3 is 4, and 4 minus 2 is 2, and this statement down here is wrong. So that's exactly what we want. We want it to be the case when numbers up top don't work out, the translated version doesn't work out. Well, that makes no sense. It's making me frowny. Okay, all right. But now let's see if when it does work out, will things be good? Let's do 1, 3, and 5. 1, 3, and 5, so this is A1, A2, and A3, okay? Let's do our translated version. Our translated version should be A1 is less than A2 minus 1 is less than A3 minus 2. Okay, so that means here once we translate, A1 is going to be A1, A2 minus 1 is going to be 2, and A3 minus 2 is going to be 3, right? So it's exactly what we want. Guys that don't work out up top, give us false statements down below. Guys that do work out on top, give us true statements down below. Now, I don't want to belabor this to make the video too long because I want to talk about the other method. But if you think about it, any statement that's true up top will definitely work down below. And any set of numbers down below will correspond to a statement up top that works out. If you don't believe me, let's pick some numbers like 1, 3, and 4. And I'm going to do this in reverse, so my bad. So 1, 3, and 4 are the numbers down below. Okay, I'm going to imagine. And remember, down below, there's no restriction. We just want true statements. So it is a true statement that 1 is less than 3 is less than 4. But I want that to correspond to a guy up top that makes sense. I'm going to go backwards. So this is just A1. So 1 is just A1, so it's going to be 1. Okay. But then what is 3? 3 is our translated statement. And our translated statement is this entire phrase here, A2 minus 1. So if A2 minus 1 is 3, then A2 is 4. Okay, so we're going to have 1 and 4. Okay, and then A3, well, remember, this guy is A3 minus 2. So if A3, sorry, it's becoming messy, minus 2 is 4, then A3 must be 6. So if we go back, 1, 4, and 6, well, obviously that statement's true, but 1, 4, and 6 is a set of numbers that will work for us because they're not back to back. Okay, so if you think about that for a little bit, it'll be clear that it does work out nicely. But now the question is this. Up top, we have the sort of numbers we want, like 1, 3, and let's say 10. But down below, what are the numbers that and we know that these come from the numbers 1 to 10 with this bizarre sort of restriction. But down below, remember, we're just getting true statements down below. So there's no restrictions on the numbers, you know, like you can have 1, 2, 3, 1, 2, 4, whatever, it works out. But down below, where are the numbers coming from? Well, A1 remains A1, so it can be as low as 1. But A3 would be our biggest number, right? The biggest A3 can be initially is 10. But down below, it's going to be A3 minus 2. So it's going to be 10 minus 2, and it's going to be 8. So we actually get the numbers from 1 to 8. So now if you believe this, we can count using our translated version because there are no rules down here. You're just picking out 3 guys, and if the numbers are 3, 4, 5, that's totally fine because when you look at the original numbers we're looking at, you translate them back up top, they'll have gaps between them. So if we do that, we have 8 guys, you want to pick out 3, and the answer is actually A choose 3. Okay? All right, so now I want to do one more thing. I want to do this a completely different way. So remember our answer from before is 8 choose 3. Remember we're going to have the numbers from 1 to 10, and we're going to pick 3. And we need everyone to be non-consecutive. Okay? All right. So that's what we can do, how we can do this. So another way to think of it maybe is something like this. Let's take our 10 guys here. Now we're going to pick out 3, right? So they're going to be 3 guys that we choose. We'll call them choose, choose, choose. But then the rest we're not going to use. So let's say let's call them no's. In fact, instead of doing it this way, let's say we have 3 guys that are yes, 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 right? And then, well, 3 minus 10 is 7. So 7 guys that are no. Sorry, the hammer is getting sloppy. No, 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 no. Okay, well, that would be 6. Let's make it 7. Duh. Okay. All right, and let's imagine putting them in a row or in a line. But the requirement, though, now we're going to kick in the requirement. They're not consecutive. So you can't have something like this. We won't finish this. But you can't have this because the 2 yeses would be right next to each other. So what you need is you always need at least 1 no between the 2 yeses. So maybe a nice way to think of it is, let's take these 7 no's and I'll write them like 1, 2, 3, 4, 5, 6, 7. Okay, 7 no's. But where could the yeses go? You can't squeeze 2 yeses between the no's, right? So what you really have is you could put 1 yes here if you wanted, but no more than 1. And you could put 1 yes here and here, right? And here, I'm just actually going to draw all these out. Okay. And now if you think of it this way, each box corresponds to an n. So there's 1, 2, 3, 4, 5 on the left side, 6, 7, and 1 extra on the right. So it's 8. So there are 8 spots that our yeses could go in, right? And how many do we need to pick out? We need to pick out 3. So let's, for example, pretend we picked out this to be a yes, this to be yes, and that to be yes. So clearly the way we're doing this, there's 8 choose 3, which already looks good, right? But we want to justify it just a little bit because it's nice we picked out yeses and nos. And definitely if you had yes, yes, say yes here or yes, yes, yes there, those would be different guys. But the actual question asks about picking out numbers, not just yeses and nos, right? But it's this ordering from left to right that we're going to always maintain that'll help us translate back. So again, it's this sort of this like translation game we're always doing. So in this particular setup, we had yes, no, yes, no, 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 sorry, yes. Okay, and once we have these guys written down, we'll always follow the order of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that tells us the numbers we picked out were 1, 3, and 10. Okay? All right. So really nice. 2 completely different ways, at least in my mind, but you end up getting exactly the same answer. Right? So not too bad, right?